I'm Dr. Binu. In our artificial intelligence and machine learning algorithms fundamentals, the fourth topic in the third unit is a concept of overfitting and underfitting. What is meant by overfitting in machine learning? Overfitting refers to a scenario when the model tries to cover all the data points present in the given dataset. The model starts catching noise and inaccurate values present in the data set. This is a drawback actually in the overfitting, which also reduces, because of this, it reduces the efficiency and accuracy of the model. The overfitted model has low bias and high variance. The diagrammatical representation of overfitting is represented in the diagram, which provides the area of the house as well as price of a house here, which is tries to cover all the data points. Because of this, it collect the noises as well as all the inaccurate values. Because of the accuracy as well as efficiencies automatically reduces. What are the reasons for overfitting? Noisy as well as unwanted data is also getting into the training data. High variance in the model, so the model is very complex, not using resampling technique. These are the reasons for the overfitting. In overfitting model, the accuracy score is good and high during training, but it decreases while testing. But we can avoid the overfitting. The methods to avoid the overfitting are: we have to use cross validation techniques, using regularization techniques, then we have to implement the ensampling techniques, picking less parameterized or complex model. Then we have to train the model with the sufficient data only, the removing the unwanted features, then early stopping the training. By implementing all those things means we can avoid the overfitting of data. Then what is meant by underfitting in machine learning? Underfitting is just opposite to that of the overfitting. In underfitting occurs when our machine learning model is not able to capture the underlying trend of the data. An underfitted model has high bias and low variance. Here, it doesn't take the required data. Because of this, the accuracy is in this method is also the accuracy is reduces. What are the reasons for underfitting? Noisy or garbage values are added into the training data, high bias in the model, less training data, the model is simple. Then underfitting in machine learning, in this underfitting, the model performance is, the accuracy score is very low during training as well as testing. We can avoid the underfitting also by means of doing some proper steps. Pre-processing the data to reduce the noise in the data. More training should be given to the model. Increasing the number of features in the data set. Increasing the model complexity. Then also increasing the training time of the model to get better result. Good fit model in machine learning. A good fit model is a balanced model which is not suffering from underfitting as well as overfitting. This is a perfect model which gives good accuracy score during training and they equally perform during testing also. We can detect the overfitting, underfitting as well as good fit data. In the classification, if we are using the classification algorithm, means the first diagram shows the overfitting, then the second diagram right fit, the third diagram shows underfitting. In regression also, the first diagram represents overfitting, second one right fit, third one underfitting. In overfitting, the training data, the error is training as it is low, the testing the error is high. Right fit, in both the cases the error is very less. In underfitting, in both the cases, that is training as well as testing errors are very high. We can compare the overfitting and underfitting as well as good fit model. In the model performs well on a test set means that is good model. performs well on a training set only means that is called as overfitting. If it is not good in both the categories, means it comes under underfitting. What is meant by ridge regression? Ridge regression is the type of regression in machine learning and which is usually used when there is a high correlation between the parameters. This is because the correlation increases, the least square estimates give unbiased values. The co-linearity is very high, there can some bias value. Therefore, we have to introduce a bias matrix in the equation of ridge regression. It is a powerful regression method where the model is less susceptible to overfitting. Another one type of regression is available, that is lasso regression. Lasso regression performs regularization along with feature selection. It avoids absolute size of the regression coefficient. The results in the coefficient value getting nearer to zero. This property is different from ridge regression. The lasso regression represented by means of the equation. Then another type of regression is Bayesian linear regression. It is used to find the value of regression coefficients. In Bayesian linear regression, the posterior distribution of the features is determined instead of finding the least squares. Bayesian regression, linear regression is a combination of linear regression and ridge regression, but is more stable than simple linear regression. Then another type of regression is decision tree regression. The decision tree regression, which works on the principle of some conditions. It is efficient and has strong algorithms used for predictive analysis. It is mainly attributed that include internal nodes, branches, and terminal node. Then random forest regression. Random forest regression, it comprises an enormous amount of individual decision trees that work as a group or an ensemble. Every individual decision tree is the random forest. Let's have the class prediction, and the class with the most votes is considered as the model's prediction.